next section, 5.6 inverse trigonometry function. So this is review trig, which most of you or all of you probably have already. So let's say if I want to find r sine of negative 1/2, I set it equal to y, and then I take side both left and right. So the left hand side I would have sine of y, the right hand side I'm just gonna have negative 1/2. So make sure you read the book that the domain for this inverse function x gonna be greater than or equal to negative 1, less than or equal to 1. Y would be greater than negative pi over 2, which is over here, and less than pi over 2. Basically it's on the first and the fourth quadrant only. So we have sine of y equal to negative 1/2. Since it's just these two quadrants, you will see that 11 pi over 6, sine of 11 pi over 6 is negative 1/2. So your y would equal to 11 pi over 6, but your y is r sine of negative 1/2. So r sine of negative 1/2 is 11 pi over 6. Alright, same idea, I just do one more example for arctangent of square root of 3. I set it equal to y, then I take tangent of in both sides. Then I have tangent of y equals square root of 3. Again, read the book. The domain of tangent, inverse tangent, x can be negative infinity to positive infinity, but the range is only going to be negative pi over 2 to pi over 2, which is only first and fourth quadrant. So tangent is sine over cosine. So we want to find the y here that satisfies square root of 3. If you look in the unit circle, pi over 3, cosine is 1/2, and sine is square root of 3 over 3. If you put in this fraction, is pi over 3. So my y right here is pi over 3, but my y is arctangent square root of 3. So arctangent square root of 3 equal to pi over 3. Let's solve for x. I have arctangent of expression to x minus 3 equal to pi over 4. So I take tangent both sides again to get rid of this. So I end up with 2x minus 3 on the left hand side. On the right hand side I have tangent of pi over 4. Pi over 4 is just sine over cosine, so sine is square root of 2 over 2, cosine is also square root of 2 over 2, but you reciprocate it, so you get 1. And then you just solve for x. X turned out to be 2. So let's take a look at calculus next section. Hi everyone, let's finish our last section here, 5.6. Before go to derivative here, I just want to show one example. Let's say they want you to evaluate sine arctangent 3 over 4. What would you do? I let theta is equal to arctangent of 3 over 4. Arctangent of 3 over 4, it means that you have an angle, tangent theta. Theta is an angle, is equal to 3 over 4. So if you draw a right triangle, this is an angle theta. Tangent is opposite over adjacent. So if you use Pythagorean theorem, it's just going to be 3, 4, 5. I just make it easy for you. Then sine theta would equal to sine theta would be opposite over hypotenuse, which is 3 over 5. But net theta is arctangent 3 over 4. So sine of arctangent 3 over 4 is 3 over 5. Alright, this is all the definition of derivative of the inverse trig function. So it's in the book, and I'll give it to you in the test. Let's take a look at the example. Let's say if I have g of x is equal to x squared arctangent of 5x. So I'm going to use the product rule here, alright? So x squared is my first term, arctangent of 5x is my second term. So you're going to do first time derivative of the second plus second time derivative of the first. So first is just x squared. derivative of arc tangent 5x, I'm going to go to number 3 here. Derivative of arc tangent 5x, you're going to have 1 plus u square on the denominator, and then derivative of u. So I'm going to have 1, this is my 1, my u is 5x, so square of 5x is going to be 25x squared, and derivative of 5x is just 5. So first time derivative of the second plus second derivative of the first will be 2x, and I'm just moving around a little bit. That's the answer. Okay. So let's look at the last example here. I have f of x is equal to arc sine 3x over x, and I want to find derivative of this. So I'm going to use quotient rule. Quotient rule said that denominator times derivative of numerator minus numerator times derivative of denominator over denominator square. So numerator, denominator is just x times derivative of numerator. So our side, we're going to use the first property here. So you're going to have square root 1 minus u square on the denominator and derivative of u on the numerator. So I'm going to have, let's see, 1 is just my 1 minus u. So my u is 3x. Alright, my u is 3x. Look at this, that's 3x. So I'm going to square it. If I square 3x, I have 9x squared. Numerator will be derivative of u. U is 3x, so derivative of u will be 3. Minus denominator times derivative of, minus numerator times derivative of denominator divided by denominator square. Alright, we finished 5.6. See you next time. Bye.